We could always use this one. Let's see. Okay, so I see audio on. Oh. Hey, I can hear myself in the stream now. Alright, well, it sounds like we have audio finally. So we'll just kind of ignore that microphone for right now. And let's mute the camera mic and see if that gives us just no echo. Wait for the stream to catch up. Sorry. Okay. So it sounds like we actually have the audio figured out now finally. So that's pretty cool. So we can finally kind of get started here. I guess. Basically just going over my little tricorder project that I've been working on for, I guess, a couple of weeks now. But I've finally gotten it to a point where it's basically like a kind of a usable prototype, which is cool. As you can see, it is just a prototype board for now. But I'm going to kind of break down the hardware that goes into it, and maybe I'll do another stream or make another video talking about the code and that stuff. It's pretty simple overall, pretty basic as far as electronics projects really go. For me, it's probably the most complex electronics thing that I've built so far. So it is, let's go ahead and zoom in here a little bit if we can. Nope, I think we're already zoomed in all the way. But anyway, so this is the Arduino Nano 33 BLE Sense Rev 2. It's an ESP32 board, and it has a whole bunch of onboard sensors as well. So if we get up close and the camera will focus and I can get it in the picture. Focus. Yeah, close enough. There we go. So you can see it's got all kinds of little sensors packed on there. There's a barometer, there's a microphone, there's a magnetometer, accelerometer, there's Bluetooth. I mean, kind of the only thing it doesn't really have as far as these little kind of project boards go that you might want is GPS. But thankfully we kind of can fix that. So that's the microcontroller that we're using for the project. I picked this one mostly because it already has so many things built in and on board. That kind of made things a lot more simple. So that's cool. To display everything, we're using two different screens. This is a color OLED. It's a SSD 1331, I believe. Let's get that pulled up here, and we can kind of show you as we're going here. There we go. So this is the one that I am using here. I just got it on Amazon. As you can see there, it's about $13. I think you can get them for, cheaper, particularly if you buy a couple of them. But that's the color one. And then this is the good old SSD 1306, which is the two-color. Do I have that one up here too? I thought I had. I guess I didn't. Well, let's do this. SSD 1306 OLED. And yeah, I mean, as you can see, they're pretty cheap. So here we go. I think probably the exact one I got, but for $7 or so, you can get the little 2-color. So it just has the top line, or top 2 lines technically, are yellow, and the rest is blue, which is, you know, generally pretty cool. So and then for the rest of the hardware, because it's pretty simple, it's basically just a bunch of pin headers, and we'll go back to the main camera here for now, and we'll get you actually in the picture here. So it's mostly a bunch of pin headers, and there's a couple of resistors and a switch, an IR LED, an IR receiver, and then some buttons, which you could make a button panel like yourself, but this one I had because I have a bunch of FPV cameras from when I was flying drones a bunch, and they all the analog ones at least used to come with these, so I got like a half a dozen or more of these things laying around. And basically it's just a resistor tree, so depending on which button you press, it'll change the resistance, and it reads that on an analog pin. And then beeper and a GPS, and then this is just a little USB charge control for the battery. So the way it all kind of works is the buttons are just read on an analog pin, I believe A7 for the setup. So depending on the analog value that's read from the serial, it'll give you a different value, so you can change through the menu and so on. Power switch, of course, battery. The second plug here is actually for the like battery monitor. The way that's done is through a voltage divider. So I have two 10K resistors, and when you pull the voltage from the middle of that series of 10K resistors, it divides the voltage in half. And then you can use math to multiply it to get the correct value. And the reason you have to do that is because the Nano 33 does not like voltage is higher than 3.3 volts. So I think the maximum it'll tolerate is 3.6, but it doesn't like to do that very long if you can avoid it. So putting full battery voltage, which is 4.2 volts, onto that 3.3 input pin makes it not happy. So we use the voltage divider to cut that in half. So at full battery it would be 2.1 volts, which is well within the 3.3, and you multiply that times 2 and you get your actual battery voltage. So that's pretty cool. So let's see what else we got here. I think that's all the basic like hardware stuff. The battery is actually two 3000 milliamp 1S batteries just in parallel, and I just put a little BMS on there so it doesn't overcharge or anything. These are batteries that were given to me by my brother's girlfriend, which is actually pretty cool. They're from, I believe, like JVC or JBL or Bose or whatever. The little Bluetooth speakers, the pod ones. So 6,000 milliamps will run this thing for a surprisingly long time. So we'll go ahead and stick everything back on the board here real quick. Yeah, put it in the right direction. And then we'll go ahead and fire it up. And you can see what we got going on there. So do believe we are in business. This one has an extra pin, so okay, good. So everything on the proto board, that's what we look like. So hopefully we can do this without too much glare on the screens and everything. If we turn it on, you'll see the little boot up and everything. Just realized it's backwards. Let me see. Hang on. Let me see if I can flip that real quick. Hey, there we go. I think you can actually see that now. So, as you can see on the home screen there, we have UTC and Central Time, which is where I'm at. Below that, it's a little harder to read because it's backlit, but that's the date. And then we have our main menu. The functions are Atmo or atmospheric, nav for navigation, dB for the dB meter, metal detector, EMF detector, IR receive, IR send, and then just the battery monitor. Which eventually I'd like to add a few more functions as far as like system monitor or whatever there. But under the atmospheric, we have, if we can get it to focus on the screen, that would be nice. Maybe we can manual focus here. Yeah, this one don't have a switch and I can't find the button. But anyway, we have temperature, temperature, dew point, humidity, and pressure. And you can change the... Will it focus at all? How about if I get real close? Will it focus there? Focus. Focus. Kinda. There we go. You can change the temperature, pressure, and or temperature and pressure, I should say. You can change those between Celsius and Fahrenheit, and kilopascals and inches of mercury. So depending on, you know, your favorite flavor, you can change that there as well. And then if we go back, I'm going to skip the navigation for now just because it has GPS coordinates and don't feel like giving away my precise location at the moment. The dB meter, it'll show the dB meter on the screen there, and the bar goes higher and lower. As you can see, you can kind of hardly see it because it's backlit white, but it's green. If it goes up above 70 dB, it'll turn yellow, and then I believe I think I have it set for 90. It'll turn red. So where like it starts to actually get really actually loud. And then on the bottom screen there, it'll show the max dB or the peak from I believe it's from the first time that the function runs after it powers on. So it'll keep that, I think, after you exit the function. But once you restart it, it'll reset that. And then just like the raw sound measurement from the serial, basically. And then if we go back, we got the metal detector. And like it says, it's a metal detector. Let me find here's a piece of metal. And if we can get it closer, you can see the closer it gets. I think it's mostly grumpy because I have it in my hand and there's so much other EMF, but you can see it changes to metal detected. It's a little hard to read there, sorry. I need to adjust the sensitivity there, I think, a little bit so it's a little more useful. You don't have to like touch it so much with metal to get it to work. And then the EMF meter is kind of the same thing, only for EMF. So, and not necessarily, I don't know if EMF is necessarily the right, um, acronym or whatever. It might be EMI, but it electromagnetic um, energy. So EME maybe. Um, but you can see there's a whole bunch of EM in here because right now it's close to my phone. The camera, as we get it closer, will it? No. But my PC is right here, so a whole bunch of electrical noise in here. So it's definitely picking that up. And then the last two are the IR send and the IR receive. So the IR receive is a little bit lame at the moment. It will receive IR codes from a TV remote, but it doesn't work the way I want it to, really. So you can see I just pointed my TV remote at it, and that's the volume up, volume down, even though that's not the volume down, because if you press it enough times it'll change. But channel down, channel up, and anyway, you can record those for later use if you like, and then you can program them in to the IR send, which is actually the more useful, at least right now, of the functions. So if we can get in there and actually focus, you might be able to kind of see what we got here. So these are all the like real important functions for my living room TV, because the remote has gotten dropped enough times that it's almost dead. So basically I cloned my TV remote so that I can actually control my TV in the inevitable event that the remote dies. So I got power up, down, or volume up, volume down, OK, back, exit, left, right, up, down, YouTube, and Amazon. Because it's, a cheap, sharp, quote-unquote smart TV. But when you press the button, or the enter button, it will send that code. And the only thing that makes it a pain to use versus just a regular remote is instead of just pressing the button, you have to select the button and then press enter to send that code. But it sure beats not having a remote, because TVs built in the last 10 years only have a power button for some reason. But anyway, so that's oh wait, we got the battery function. I'll show you that one too real quick. So the main menu is a touch laggy since I added the time on there. That's something I gotta debug. There we go. So you can see right now it's reading 3.8-ish volts, which is roughly half. And you can adjust that scale. I have it scaled from 3.35, I believe, to 3 or 4.2. So, depending on how conservative you want to be with your battery and so on. But this has been running almost continuously for 3 days, I think, without charging. So we're doing pretty decent on the battery life, I think. And that's kind of another funny thing about the Nano 33 is being a 3.3 volt board. It's really sensitive to higher voltages, but it can take an input voltage of up to like 21 volts or something. So that's like what, 6S, I think, which is a little bit crazy. But when you plug in USB, upload or sketch or whatever, it will actually output a voltage on the VN pin, which I don't know why, and I don't think it's really supposed to do that. So technically, if you have it powered on with the switch, if you have the switch on and you plug it into USB to upload or whatever, it will charge the battery, even though it's not supposed to. So this little charge controller is sort of semi-redundant, but I think this is actually better because there's a little resistor on the board that gets crazy hot if you charge it through the serial USB there. So plus this will charge it faster, which is better anyway. So that is basically everything. There's a little beeper. I don't know if you heard the little startup tone when I first powered it on, but I'll probably program in button beeps and stuff eventually to kind of make little confirmation tones for when you press the button and so on. But let's do this. Let us kind of do a quick rough look at basically what we got going on as far as like the prices of all this stuff. So a lot of these things are hard to get in onesies and twosies. So if you do, it might be a little more expensive that way. Otherwise, you basically, hopefully you have other projects you want to work on. So so you can see the screen. The smaller ones are about $7 on Amazon if you buy them one at a time, or the more simple OLEDs. The color OLED is about $13. I think you can get them plus or minus, a buck in the onesies. And you can buy multiples to get them a little bit cheaper. You could technically use 2 of these color OLEDs, but there's more wiring because the 1306 is just SCL SDA, so it's just I squared C, whereas the color one is SPI, so it uses a few extra pins. But then you have, let's see, so after the screens, this is the BMS that I used, quote unquote BMS. It's basically just a little protection cell or protection board for the battery, so it just kind of helps to prevent overcharge, over discharge. And as you can see, 10 pieces, or 10 of them for $6. So this is the switch that I got for the power switch, although I am designing a PCB, an actual PCB for the project, so I'll probably end up using something a little bit more like this, because I think the way I'm designing it is 4 through hole. So, but as you can see, you get, basically a lifetime supply of switches for $7. Beepers are kind of the same thing. If you get one of the little Arduino like development kits and that stuff, they will usually have one. But otherwise, $10 you get 20 of them, which that's a pretty good amount of beepers unless you're doing a lot of electronics projects. These little guys is the charge controller. It's just a TP485 or 4056, really common. May not technically be the best one because it's, like they say here, it's kind of designed for 18650 or whatever. I'm not sure, how critical that is, but you get 3 of them for $6. So if you got another project or if something else that's not charging correctly, you can put your own charge controller in there. Monitor we did already. These are the pin headers. This is the kit I just bought recently to make my life easier, because you can buy these in just the long sticks and then cut them down. But it's nice to just have an assortment. That was $10, so not too terrible. The most expensive thing by far is the board itself, or the Arduino. you could probably use like a regular ESP32 or something if you really wanted to, but this, I had started this with a regular Arduino Nano and quickly realized it was not going to have the horsepower to run all this stuff. So that's why we went with the Nano 33. And because this one had all this stuff on board, that made wiring and all that stuff a lot easier, so we went that way. But this one is roughly $40. You could probably get them a little cheaper if you look around, and I think you can get them for a little cheaper if you have them without the pin headers soldered on already. I'm not afraid of soldering, so that's the way I went. But anyway, and the last thing for the current build, other than some resistors, is the IR receiver and IR send LEDs. You can get this kit, or a kit like this, that basically has everything you need all together, and more than you need for this one project, for $7. Oh, that's right, not the last thing, sorry. So there are a couple of resistors, but the actual last thing is the GPS. So this is again something I had left over from quad building from Jones. So Race Day Quads is where I got this one. I've had this one forever. It's their little Mini 8. This is an M8N U-Blocks, GPS module. What I would do if, and what I want to do, is to upgrade probably to the M10 or M100. This is the HGLRC one. Let me scroll back up here. And it's roughly the same price. So this is actually a faster, it picks up satellites quicker, and it uses more satellites. So it's a little more accurate and a little quicker to respond. But it's also basically the same price. So you might as well get the newer, better one for actually 50 cents cheaper. So if you want one that has a built-in magnetometer as well, so you have like a dual compass setup, you can get the M100 Pro, which is interesting because it's the Pro one, but it's actually a couple of bucks cheaper. You could use this one as well and just not use the I2C wires, and just use the UART, and then you just use the GPS that way. Generally, though, these ones are going to be a little bit bigger because they have the magnetometer in there. I'm not 100% positive on the dimensions here, but basically that's it. That's the hardware. There's a lot to it, but it's really not crazy. In reality, it's fairly simple. Like I said, I'm hoping to, I'm working on a design for the PCB, so that way everything is easy to build. You just got to put it on there. My camera died, so I think we are I think we're back to the browser if we want to actually see anything. So I will probably do another stream in the next week or so, hopefully, and then we can go over the code and all that stuff. It's far more complicated than it should be, more than likely, and anybody who knows how to code is probably going to think it's half-ass or total ass, but I'm not a coder, so cut me a little bit of slack there. If you do want to check it out, it is on GitHub. It's GitHub Big Data Pimp, and it's the only project I have on there for the Tricorder, so you can check out the source there. If you'd like to contribute, I would absolutely appreciate it. If you know how to code better than I do, then even better. I'm always down for assistance and making things actually good. So that's it. If you have questions or anything, drop them in the comments, the chats, or whatever. You don't have to subscribe or any of that stuff, but if you wanted, that'd be rad. And hopefully I'll be back soon. I'll try to post a note on my community notes before I actually go live next time, so that if anybody cares, they may have a head up. I can't think of anything else, so you guys have a good one, and catch you next time.